Hello, and welcome to Chapter 2. The first thing we're going to start off with here is transformations again. This is going to look familiar to what you did during Unit 1 or Chapter 1. Actually, it's almost exactly the same. The only difference is instead of doing linear and absolute value graphs, we're going to be doing quadratics. So, a couple things about quadratics. Understand that a quadratic equation is an equation here that has an x squared. That's what defines a quadratic. Quadratic function is some variable squared, and that is quadratic. The shape of a quadratic graph is called a parabola. And so that looks like these here. They look like U's. That is a parabola. It can also be upside down if you flip it across the x-axis. And finally, the vertex here, the vertex is simply the bottom point, or if the parabola were upside down, it would be the top. So it's whatever the bottom or top of that parabola is, depending on its orientation. We'll talk about vertex form a little bit later, and I think next class, so I'm not going to worry about that right now. But what you need to know here is that with transformations, it is exactly the same thing. Notice how inside here, there is a left and right movement. So if you pretend that there are bars here, just like there were with absolute values, this moved it left and right. So the only difference here is you now have parentheses and a squared instead of those bars like absolute value. But the movement is exactly the same. Here, with the number on the outside, that K, this acts as your D here, moving it up and down. Same concept. And the negative on the outside does flip it over the x-axis. And then anything here next to the x squared, that A value, does do vertical stretching and shrinking. So this is going to be pretty quick because you already know most of this stuff. The only thing that's going to be new is just that this is a parabola, this is a quadratic. So your parent function, and there's a bell, your parent function is going to be a U kind of shaped parabola rather than a straight line V-shaped absolute value. So describing the transformations is the same. So this negative on the outside causes a reflection across the x-axis. And then this 3 on the inside there, just like it would in absolute values, it moves it opposite. So that's not to the right 3, it's actually left 3. And those are the transformations. So you'll see the similarities to absolute values right away. On the outside here, since this is less than 1, this is going to be a vertical shrink by 1/2, or by a factor of 1/2. The one on the negative 1 on the inside moves it right 1, and the positive 1 on the outside moves it up 1. Exact same transformations as you did with absolute values. The only difference here is it's quadratic. We can graph these. The only thing that makes this a little bit more challenging is the fact that it's a quadratic. Lines and absolute values were perfectly straight, so it made it easy to draw. These kind of make it a little bit more of a challenge. Here in number 1, you see that there are no parentheses. Normally you would have parentheses squared. What that tells you when there is no parentheses here is that there is no horizontal movement, because inside the parentheses it moved left and right. So there is no horizontal movement. All I have is simply moving up 4. So I'm going to go up 4, my vertex. Actually, I'm going to do my parent function first. My parent function starts at 0, 0, and it will go through the points 1, 1 in both directions. But then from there, it just curves up. Instead of going straight diagonal, it does do a curve. So now what I'm going to do, because all of these need to have a parent function, I'm going to paste these. And so we have them in the right place there, and this one too. And now I can go ahead and draw the parent functions, the transformed functions for these. Since this one is up 4, I'm simply just going to move that up 4. These points are up 1 over 1 just for the first points, and then from there it curves. And so there is a translation up 4. Here we have this moving it to the right 1 and this moving it down 3. So right 1, down 3. Now this gets a little weird here because these go by 2s. So right 1, down 3 actually places it right 1 and then down 3. Puts it kind of in the middle, which is kind of weird. So when you go up 1 over 1, it's still in the middle. But then I draw my curved graph. Something like that. So that's right 1, down 3. This one, the negative on the outside will flip it upside down, and then this moves it left 9. These go by 3s, so 9 is right here, but now it's going to be flipped upside down. So instead of going up 1 over 1, it will be down 1 over 1 in both directions. And look something like that. You don't need to be perfect with these parabolas. It just needs to be close. It's kind of hard to draw them very accurately. It's not like a straight line where you can have, Notability make a straight line for you. But it just, as long as it's close, it's fine. I'm not going to do the rest of these. This would simply just move it down 7. 5 and 6 you are not going to see because vertical stretching and vertical shrinking is it's easy to recognize, and you could say that it was vertically shrunk by 1/3, but drawing it is a whole nother story. Because quadratics are not straight lines, having a 1/3 in front really changes it, and it's really hard to graph that accurately. And this has a horizontal stretch, and we don't do horizontal stretches in Algebra 2. So you don't need to worry about those. You could just cross them out. The last one here, I'm just going to write the answer, but I would like you to try to figure out all the transformations that happen here. So if you want to pause the video, hit pause, and then write down all the transformations that you see here. Here are the answers to this. So you should have a reflection across the x-axis. Bell again. A negative makes it a reflection across the x-axis. The 10 there is a vertical stretch, a very large vertical stretch. A factor of 10. The -5 moves it right 5. And the +7 moves it up 7. And so there's the answers that are there. You should have gotten those in no particular order. Okay. Last one, and this is outcome 2. The last one is then to now write the equations of the transformations. So what you need to see here when looking at these graphs is you need to see that it originally started here, but now it's over here. What happened to it? Well, it looks like it went left 3 and then up 2. So how do we write an equation with left 3 and up 2? If you remember, instead of doing bars like this, you're going to be doing parentheses with a square. Left 3 would be +3, so x plus 3. And then up 2 would simply just be +2. And that's that. It's really that easy. That's your function right there. Over here, this just simply moves left 3. So again, parentheses squared. And this is just, not left 3, sorry, right 3. And it's going to be right 3 is x minus 3. There's no up or down movement. It is upside down, so I do need to recognize that it is upside down. So that negative will go on the outside as a reflection. But there is no up or down movement, so I don't have that extra thing on the end. Last one here. This one is also inverted, but this one does not have any horizontal movement. If you notice here, there is no horizontal movement. It just simply moved up 2. So just like I told you before, when there is no horizontal movement, you won't see any parentheses. That's what I told you earlier. Since there's no parentheses, there's no horizontal movement. Well, the same thing can be said in reverse. If there is no horizontal movement, then there's no parentheses. So I can just put the x squared. It does go up 2, so I have that, and it is inverted. It is upside down, so I do have a negative there. So, and that is it. That is transformations of quadratics. Really short, super super, or still relatively easy, hopefully, now that we've done transformations before. So thanks for listening. Bye.